Hey everyone, and welcome to The Explainer. Today, we're completely breaking down the high-flying world of a BE in aerospace engineering. We are mapping out the whole shebang, from the core syllabus you'll study to your future salary prospects. If you've ever looked up at a commercial jet flying overhead or watched a rocket launch and thought, what does it actually take to design the machines that conquer the sky? Well, you are in exactly the right place. We're going to unpack the actual realities of this degree and figure out exactly what it means for your future career. So let's kick things off by diving right into the big question, looking at where the industry is heading right this minute. Is aerospace engineering a good career choice in 2026? Honestly, it's a completely valid question for any student plotting out their academic future right now. The world is changing incredibly fast, and traditional engineering branches, they're evolving. But the short answer to this question, absolutely, yes. And the data completely backs this up. Get this. The global aerospace engineering market is projected to hit a staggering $62.5 billion this year. That massive number is being driven by commercial aviation, defense spending, and those booming space exploration programs we keep hearing about. This immense market growth means the scope and future demand for this specific engineering branch are, quite literally, skyrocketing. We're seeing this massive push for fuel-efficient aircraft, advanced digital twin simulations, and a huge expansion of satellite constellations. All of that translates directly into sustained, long-term demand for highly skilled engineers. Okay, here's our flight path for today's explainer. We'll start with the future of flight, head inside the BE syllabus, look at essential aerospace skills, compare emerging tech and trends, break down career tracks and salaries, and finally ask, are you ready for takeoff? All right, Section 1, the future of flight, expanding horizons. What's really fascinating here is that modern aerospace is no longer just about standard commercial airplanes. Not at all. It is this highly dynamic field blending space missions, AI-powered design tools, and autonomous drone systems. The real-world practical applications of this course extend to designing sustainable, low-emission aircraft and integrating machine learning to simulate complex aerodynamics. You aren't just learning to make things fly, you're learning how to make them fly smarter, fly further, and do it entirely without a human pilot in the cockpit. Moving right along to Section 2, inside the BE syllabus, mapping the academic journey. Now, looking closely at the official 2025 curriculum regulations, like those from Anna University, you immediately see it lays down a seriously rigorous foundation. It perfectly blends heavy theoretical concepts with intensive practical labs. Your first year mostly lays the groundwork with applied calculus, physics, and engineering drawing. But let's skip ahead and focus on the core aerospace subjects that are really going to define your degree. So the crucial takeaway is how the degree actually progresses. Year 2 is all about building your mechanical foundation. You learn exactly how air interacts with an aircraft and the baseline mechanics of flight. Then, Year 3 tackles advanced systems like propulsion and avionics. Finally, Year 4 is completely focused on practical hands-on execution. This logical progression ensures you deeply, fundamentally understand the physics before you even attempt to engineer those complex flight systems. Let's talk about Year 3 for a second, because things get really intense here. You master the forces of flight through advanced thermodynamics, aerospace propulsion, and a little something called computational fluid dynamics, or CFD. CFD is absolutely crucial. It's essentially using incredibly powerful computers to simulate how air flows over an aircraft. This means you get to test and optimize your designs in a virtual environment way before any physical prototypes are ever built. You'll also dive into avionics, which is the integration of all those complex electronic navigation and communication systems. Then by Year 4, you synthesize all of that intense math and physics into an actual capstone aero design project. If you ask recent engineering grads for their single best piece of study advice, they will almost always tell you to prioritize your hands-on industry internships. This practical application is the ultimate bridge from being a student to becoming a professional. And honestly, it heavily dictates your placement records and your early career success. Which brings us to Section 3, Essential Aerospace Skills, your toolkit. To really succeed out there, you have got to build these core proficiencies step by step. Step 1 is transforming your concepts into 3D models using CAD software like CATIA or SolidWorks. Step 2 is aerodynamics optimization, basically maximizing lift while minimizing drag. Step 3 involves deep knowledge of propulsion systems, understanding everything from traditional jet engines to the latest hybrid tech. And finally, Step 4 ensures all those intricate electronic systems play nicely together in mission-critical projects. But you can't stop there. On top of those basics, mastering virtual testing through CFD simulations and really understanding how lightweight materials behave under extreme pressure will make you an incredibly sought-after engineer. Material science is huge right now, guys. Understanding how modern composites, ceramics, and advanced lightweight alloys can replace traditional heavy metals without sacrificing an ounce of strength is a highly specialized skill that top companies are literally desperate to hire for. Let's move to Section 4, Emerging Tech and Trends, Future-proofing your degree. The industry is shifting, and it's shifting fast. While traditional jet engines and basic alloys are definitely your foundation, the future is completely dominated by AI-driven predictive maintenance, electric and hybrid propulsion, and digital twin simulations. This is exactly what sets modern aerospace apart from traditional, older mechanical engineering branches. You aren't just learning standard old-school mechanics. You are preparing for a landscape dominated by autonomous, urban air mobility. Your degree absolutely must be future-proofed. All right, Section 5, the part you've probably been waiting for. Career tracks and salaries, the financial flight path. Whether your ultimate goal is working on classified national defense projects with DRDO or building next-gen commercial aircraft with Boeing, the opportunities both domestically and globally are just immense. You're looking at industries ranging from aircraft design to spacecraft engineering and even autonomous drone services. Top employers in India include giants like ISRO, HAL, and Tata Aerospace, while at the same time, an incredibly booming sector of commercial space startups is fiercely hunting for fresh talent right now. Let's talk numbers. In India, right out of the gate, you can expect an entry-level salary somewhere between 4 to 8 lakh. As you grow into a design or systems engineer role, that bumps up to 6 to 12 lakh, and it easily scales past 20 lakh a year for senior specialists. It's a highly lucrative field, especially as you gain experience and specialize in high-demand niches like AI integration, sustainable aviation, or advanced propulsion. And if you're eyeing overseas jobs, well, the demand there is just as fierce. To put it in perspective, the median salary for aerospace engineers in the United States sits at a very competitive $134,830 as of 2024. The hardcore technical skills you learn in a comprehensive BE aerospace program are highly transferable globally. This opens doors in advanced markets all over the world, where the investment in aviation and space tech is truly massive. Which brings us to our final stop, Section 6, Ready for Takeoff, Pros, Cons, and Final Thoughts. It's a bit of a balancing act, right? On one hand, the pros are phenomenal. You get to work on globally impactful, innovative projects, enjoy highly lucrative salaries, and gain skills that easily transfer into robotics and AI. But you have to weigh that against the cons. It is a fiercely competitive field. You might face some regional infrastructure limits for entry-level roles depending on where you live, and it absolutely demands that you continuously update your skills. I love this quote from industry experts at MatchTech. They say, every new skill you master could be the one that shapes the future of flight. Maintaining an insatiable curiosity for learning new software and physics principles is the absolute key to longevity in this sector. That is the reality of engineering in 2026. You just cannot afford to be complacent. You have to be a lifelong learner, always ready to adapt to the next major technological leap. So, thinking about this incredible 4-year academic journey and the massive industry growth we've covered today, what steps are you going to take today to secure your place in the future of flight? How will you fit into the AI-driven hybrid electric aerospace landscape of 2026? Let that provocative question fuel your curiosity. Thank you so much for joining me on this explainer. Keep aiming high, and I will catch you next time.